Hello friends, welcome to the Carbon Math tutorial. Today I'll be teaching geometry and I'll be showing us four important theorems in geometry. But before I unveil that, I want to remind you to subscribe to my YouTube channel, the Carbon Math Theory, and also follow me on TikTok so that you can get access to my videos and also notifications whenever I drop my content. Alright, so let's move on to the lesson for today. So guys, we have our theorems here and we have diagrams to illustrate each of the theorems. This diagram is for the theorem 1, theorem 2, theorem 3 and theorem 4. So I'm going to read the theorem and explain with this diagram. So the first theorem says that sum of angles on a straight line is 180 degrees. So we have this straight line, we call this AB. So this is straight line AB. Then we have angles on this straight line, angle A, B, and C. So the theorem is saying that when we add this angle ABC, it is equals to 180. That means A plus B plus C should give us 180 degrees. That's what the theorem is all about. So let me just try to give us an example here. Let's say this one is 50 degrees and this one is 70 degrees. So let's find the value of B. So that means A here is 50, B we don't know, and then this one here is 70 degrees. So that means 50 plus 70 is 120. So we have B plus 120, right? So let me just write B plus 120. Let me erase this and write that. So that means we have B plus 120 is equals to 180, right? Then we take 120 to the other side. We have B equals to 120 minus 180 degrees. And this will give us, that is, sorry, this should be 180 minus 120 degrees. That will give us 60 degrees. So that means we can find the value of B to be 60 degrees. So this is one of the questions that you can have and you can apply this theorem to. Now let's move on to the second theorem, which says sum of angles in a triangle is 180. That is this diagram 2. I'm going to make use of this second diagram. So we have that x plus y plus z is 180 degrees according to this theorem. X, y, and z are the angles in this triangle, right? So that means when we add x plus y and we add it to z, everything here equals to 180 degrees, right? So that means if we have one angle here to be, let's say this one is 40 degrees and let's say this one is let's say this is 50 degrees, right? Then what will be the value of x? So we can just make use of this theorem and say that we have 40 plus x plus 50 is equals to 180 degrees, right? So we can add 40 plus x plus 50. Now 40 plus 50 is 90, and 90 plus x equals to 180 degrees. So I would like to move here. So that means x equals to 180 minus 90 degrees and x equals to 90 degrees. So this is one of the applications of this theorem. So when you have a question like this, then you know what to do, right? And let's move on to the third theorem. And the third theorem says the exterior angle of a triangle is equals to the sum of the two opposite interior angles. Wow, this is so long, but I'll break it down for us. Now look at this. What it is saying is that the exterior angle, right? So this is the exterior angle you can see here. That is the angle outside. Y and Z are the interior angles. Why this one is the exterior angle? That means it is outside, exterior, interior, right? So it's telling us that look at this exterior. Now look at the angle opposite A. Can you see? This one is just, these two angles are just opposite of this. So that means what this theorem is saying is that since X is an exterior angle, having this so that these two angles are opposite to this x, then we say that x is equals to y plus z. That means when we add z plus y gives x, right? I can extend this line, I can extend this. I just want us to understand this theory very well so that we won't get confused. I can extend this line and have another exterior angle here. I can call this one A, right? Now, if I call this one A, I can call what we have here D. So that means if this is the exterior angle here, then this Z and D will be the opposite interior to this A. So this theorem, one of the cheats I want to give to you is that for you to be able to use this theorem effectively, whenever you find an exterior angle like this, you should be able to identify what are the two interior angles that will be opposite to it. Now, this is it. You can see that this is angle A, this one completes angle A, right? So when you remove this one from this triangle, for the inner triangle, the other two angles will be the opposite interior angles, just like this X. Look at this D is the one closing with this X. So when you remove this D, the other two angles you have will be the opposite interior angles to that exterior angle. So that is the way you can always know which one is exterior, sorry, which one is opposite interior angles to the one that is exterior, right? So that explains that. So that means, according to what we have here, this is A. Now Z and D will be the opposite interior angles to A now. So that means we can write that, let me clean this piece. So I wrote X equals to Y plus Z, right? Y plus Z. Then I can also write A equals to D plus Z. This is what the law is talking about. So if I also extend this line, let's extend this line. Let's have an exterior angle here. Let me call this one angle P, right? Now, I want you to tell me in the comment section which angle will be the exterior, sorry, will be the opposite interior to P. So I want you to leave that in the comment section, right? Now, moving on to the fourth theorem, states that corresponding angles are equal. Corresponding angles are equal. So I'm going to show us what do you mean by corresponding angles in the first place. So now, having these parallel lines, can you see? These parallel lines, these horizontal lines, they are parallel. Alright, now we then have a line drawn across them, which we know, we call this line a transversal, but we are not here to go deep into all of that today. Sorry, so this line is called a transversal. Now when we have something like this, a line across parallel lines like this, now I want to show us what corresponding angles are. That means angles that are in the same position. Angles that are in the same position. Now this line form angle is the three parallel lines. Now we have angles that will be on this. Now if you divide this line into this part and this part, right? So we have some angle that will be on this side. We have some angle that will be on this side, right? So talking about this side now, talking about this side, the angle here is on top. It corresponds to the angle here on top. It corresponds to the angle here on top, right? While the angle here below it is equal to the angle here below it is equal to the angle here below it. That means if I have this as A1, A2, A3, that means A1 is equal to A2 equals to A3 because they are corresponding. That means they are on the same side, number one, and they are on the same position. Can you see that? Look at this. They are on the same side. Now look at this. This one here, if I call this one B1, this B1 is also on top, right? But it's not equal to A1 because it is on the other side. So if we want to consider corresponding angle, number one, they must be on the same side, right? Of that line, they must be on the same side, and also they must be in the same position. That means A1, A2, A3 are all on this side, one, and also they are all on top, on top, on top. That is why they are corresponding, so they are equal. That means the angle here, let me start with this. B1, this one B2, and this one B3. They are corresponding because they are all on this side. B1 is on top, B2 is on top, B3 is on top. So that means they are all equal. B1 equals to B2 equals to B3, right? Then we have that means this one, and this one will be equal. So we are calling this one C1, C2, and C3. That means C1 equal to C2 equal to C3. Alright, so these are the four theorems that I'll be showing us, and I will be solving a problem that will allow us to make use of all these theorems. I'm going to apply all these theorems in that particular question. So let's look at that question. So guys, this is the example that we're going to be taking to apply all the four theorems that we have mentioned earlier. So the question says that in the diagram above, PT is parallel to RS. That is, PT is parallel to RS. And you can see they are parallel, right? Then PQ equals to PT. PQ is equals to PT. That means this triangle PQT is an isosceles triangle, right? Because two sides are equal. That's why you have Y here and Y here, because the base angle of an isosceles triangle are equal. And then also an angle SQT equals to 90 degrees. That is angle SQT is 90 degrees. So that means this place is 90 degrees. So let's write that. That is 90 degrees. You have to find the value of x. That means the angle here, right? That's what we want to find. So what is the first thing we do? So I'll be checking the process, the procedure here. So the first one I'm going to do is that we extend T and P to M and N. So we extend T and P. That means this point T and this point P. We extend them and make use of broken lines. Yes, that. Make use of broken line. The same thing here. So that is, I label it MN. So this extends to M and this also extends to N. Alright. Then, okay, I join this line, this TS. So I'm going to join it and extend it. So I'm going to make use of ruler to do that. So I draw this like this. Yes. To complete that, so we have a closed um, shape. So this line, I call it A, and this is, let's call this B. Then I also extend this line. This one should be a broken line. Should be a broken line. Alright. Then also I extend this. Can you see? I extend this both sides. So I call it CD. Right? I also extend this side. Right? I extend this side and I call this V, right? V, and this one too. I extend this, extend this. So I call this U. Where do we start from? So we consider this angle CQS. That means CQS, right? Solution again. So that means angle CQX equals to, that is Y plus 90, right? That is Y plus 90 degrees. This place makes the whole of this angle, right? This angle here, Y plus 90 degrees. That's what gives CQX. Sorry, CQX. Yeah. All right. Then let's call that equation one. Let's call that equation one. And then also this place will be 180 minus x, because sum of angle on the straight line is 180. Remember I told us that sum of angle on a straight line is 180. So this place is 180. So to get this place, we subtract x from 180. That will give us what we have here. That is, now this angle here is, let's call it angle, that is u, you can call it u v, okay, you can call it u r d, right? Because there is u r d. You can call that angle u r d equals to that is u r d equals to 180 degrees minus x, right? Let's call that equation 2. The next thing to do is look at this that we have here is an exterior angle. This is triangle SQR, right? So angle UR CQX is an exterior angle to this angle 55 and x to 55 degrees and x degrees, right? So that means since it is an interior angle to these two, I mean it's an exterior angle, sorry, it's an exterior angle to these two angles here. That means this equals to the sum of this. I have shown us in one of the theorems that I showed us earlier, right? So that means y plus 90 degrees, that is this, is equals to 55 plus x degrees. So that means um, 90 degrees minus 55 equals to x minus y. That means we have 35 degrees equals to x minus y. Now let's call that equation 3. Let's call that equation 3. And this place, this is triangle TPQ. So let's consider triangle TQT. Let's call it that way. Consider, when we consider triangle PQT, so we know that angle P plus Q plus T is 180. That is sum of angle in a triangle, right? That means angle P plus angle Q plus angle T is equal to 180 degrees. That is sum of angle in a triangle, right? Sum of angles, sum of angles in a triangle. That is that. So that means we don't know this place P, we know this place and this place. That means P is unknown plus y plus y equals to 180. So that means P plus 2y is 180 degrees. So this implies that P equals to, that is P equals to 180 minus 2y. So let's call this equation 4. Now that being equation 4, now when you look at this, I want us to look at this carefully. Looking at this, I can draw this line out for us to see. Now look at this, I want you to look at this line TP. That is this line TP here. Having this line here, then look at this one too. UV. Let's call this UR. Then we have another line UR. As you can see, we have TP. That is TP. Right? Then we have UR. So that is UR. Right? Now look at this angle here. Look at this angle here. And then look at this angle here. The angle here. So remember what I told us about corresponding angle. Look at this. This line on this side and on this side too. So this angle here is equal to this angle here. Remember I explained in that theorem what corresponding angle is to us. So this angle and this angle, they are corresponding because they are on the same side and the same position, up, and they are on this, that should be, let's call it right hand side. So this is the left hand side here, this is the left hand side here, this is the right hand side here, this is the right hand side here. So they are both on the right hand side and on top. So that's why they are corresponding, right? And remember that corresponding angles are equal. So that means this angle and this angle are equal. That means I can write that angle P is equals to angle URD, because this angle URD, right? So why do we say that? Because they are corresponding angles. They are corresponding angles. Alright. So that implies that angle P, which is 180 minus 2y, that is 180 minus 2y, is equals to angle URD, which is 180 minus x, that is 180 minus x. Now looking at this, 180 will cancel 180 on the other side because they have the same sign on both sides. So when this one comes here, it cancels out, right? So 180 cancels out 180, we are left with 2y minus 2y equals to minus x, minus 2y equals to minus x, right? So minus can cancel minus. So we have minus cancels minus, we have 2y equals to x, right? So look at this, if we call this one equation 5, call this one equation 5. Now we can put equation 5, now we consider equation 5 and 3. So this is equation 3 and this is equation 5. So look at them, you can substitute, right? So we have that. Now put 5 into 3. So we put 5 into 3. And what is 3? 3 is 35 equals to x minus y. So x is 2y, that means 35 equals to 2y minus y. That means 35 equals to y. 2 minus y is y. So this implies that y is equals to 35 degrees. Now, since y equals to 35 degrees, so let's just use 5. So from equation 5, where we have that 2y equals to x, that means 2 times 35, because that is y, is equals to x. So this implies that x is equals to 70 degrees. So therefore, the value of x that we have to look for here in this diagram, x is equals to 70 degree. So this is the solution to this question, and you can see that this question has helped us to apply all the four theorems, because we applied here, we applied corresponding angle here. Here we apply sum of angle in triangle, right? Here we applied that is exterior angle equals to the sum of the two opposite interior angles. That is three rules. What else do we apply? And then we also apply angle on a straight line here. That is x plus what we have here is angle on a straight line. So we were able to apply all the four theorems in solving this question, and that will also help us to, or that has also help us to see how we can apply these theorems in questions, and also to solve problems on our own. So if you enjoyed this lesson, give it a like, and if you have not been following me on YouTube, subscribe to my channel, and on TikTok, follow me on TikTok. I want you to like this video, comment, and also share this video to your loved ones. So see you guys again. Goodbye.